This is the fourth video in this series devoted to information theory and math card magic. Today we'll look at examples that make use of surprisal values. Now, our first example involves a video I have already posted to my channel. It's on the top left-hand side of the screen. It's called Read 3 Minds at Once. And I strongly recommend that you watch that video before you proceed with the current video here. It will make so much more sense if you watch that first. Now, if you choose not to watch that earlier video first, I can quickly give you a bird's eye view of what it looks like to the spectator, okay? So what you do is you have 3 piles of 3 cards each, randomly dealt to the table, and the spectator can do the mixing and then the dealing. Then for each of the 3 piles, what you do is you show the spectator the identity of the cards within each of the 3 piles. So for example, the spectator is now free to choose and make note of any one of these cards here for pile 1. Once that's done, you repeat those same actions for pile 2. You go ahead and reveal the identities of the cards in pile 2. The spectator is free to choose any one of these and note that down as their selection from pile 2. And finally, from pile 3, they can choose any one of these cards here. So once they've written down their selection for safekeeping, these cards are then stacked on top of either one of the other piles, and then these are randomly stacked as well. Now from there, this packet is thoroughly mixed, and that is demonstrated in the video mentioned on the top left-hand side of the screen. And then after the mixing, the cards are again set out into 3 piles of 3 cards each, and the spectator just needs to identify. I'll have the cards face down this time if that's okay. But pretend these are face up. The spectator is looking at these cards, the faces of the cards, and we ask just one question. Which pile contains your first selection? And knowing which pile contains their selection, you, as the performer, are able to immediately state the identity of their first selected card. Then you ask them which pile contains your second selection. The moment they speak the words, you're able to identify the spectator's second selection. And then finally, you ask them which of the 3 piles contains their third selection. And with that information, you can immediately state the identity of their third card. Okay? Now, anyone I've shown this to has been visibly surprised, if not shocked, that I am able to correctly state the identity of each of the 3 cards that they freely chose. So once again, I encourage you to watch that video, Read 3 Minds at Once. So what we're going to do now to tie it to information theory, let me just move these up here. We're going to first calculate the probability that I could, by chance alone, guess the correct card. And the probability of doing that by chance alone would be the following. For the first pile of 3 cards, for me to randomly guess the spectator's first chosen card, there would be a 1 out of 3 chance of me doing that. So 1/3. For the second pile, it's the same thing. There's a 1 out of 3 chance that I would just randomly also choose the card that they chose out of those 3 cards. And the same thing holds for the final pile, pile 3. I would have a 1 out of 3 chance of randomly guessing correctly the third card they chose. Now, since these are, quote, independent events here, we multiply the corresponding probabilities. So the probability of me succeeding in correctly guessing all 3 of the spectator's chosen cards is 1 out of 27. Okay? Now, earlier in this series, the work of Claude Shannon, who is the father of information theory, he gave us a wonderfully powerful perspective in interpreting these probabilities in the context of ordinary coin tosses. Okay, so if you remember, the surprisal value for a single random event that has probability p of occurring is equal to log base 2 of 1 over the probability, which is equal to, here, log base 2 of 1 divided by 1 divided by 27, which equals log base 2 of 27. And that is approximately equal to 4.75 bits. Well, I think that's close enough to 5 bits. We'll go ahead and round it up to 5 bits. And so the interpretation that we gave earlier in the series, and it does in fact apply here, is the following. The surprisal, or degree of surprise, associated with me correctly guessing the identity of all 3 freely chosen spectator cards, is the same degree of surprise one would experience in tossing 5 fair coins high up into the air, and while the coins are in the air, you call heads on all of them. And then the coins land and bounce around on the table and eventually settle down. And guess what? All 5 coins are face up. So that is the degree of surprise associated with this first performance, entitled Read 3 Minds at Once. Okay? So that would be very unlikely. In fact, try that. Grab 5 coins, toss them until you get all heads. And it would be very interesting to see how long that would take. But the level of surprise in witnessing that event is the same, or approximately the same here, as the surprisal the spectator will experience in watching this particular performance. Okay, so that's Read 3 Minds at Once.